Hello and welcome back to Math with Mrs. Becker. Today we are looking at college algebra and we are starting chapter 2 by focusing on quadratic functions. So in 2.1 and in 2.2, our main focus is to study graphs of polynomial functions. Remember, polynomial functions, they are classified by their degree. And this is something that we did study back in Algebra 2. Remember, if you have a degree of 0, it's called constant. If you have a degree of 1, it's linear. Degree of 2 is quadratic. Degree of 3 is cubic. Degree of 4 is quartic. That was that really fun chapter 6 stuff. Okay, so just to start off, let's talk about a constant function. A function in the form f of x equals c. What that means, remember, f of x is interchangeable with y. So your equations look like y equals 2 or y equals 3. They have a degree of 0. The graph of a constant function is a horizontal line because here this says to cut the y-axis at 2. Now remember, the y-axis runs up and down. So if I were to cut the y-axis at 2, I would have to go up 2 because it's positive, and it would take a horizontal line to cut through the y-axis at 2. Now this means to cut through the y-axis at 3. So again, if it's constant, it has a degree of 0. The line is horizontal. These are examples of what the equation would actually look like. The next one, a linear function. This is in the form y equals mx plus b. The m cannot be a 0 because what would happen there is you would cancel your x. And a linear function needs to have a singular x, meaning you don't have an exponent on it. It is just 1x. You have a degree of 1 when you have a linear function. M is the slope. That is our rise over run. The b is the y-intercept. That is the location where your line crosses the y-axis. Examples would be y equals, let's say, negative 1/2 x plus 3. Okay, so y is by itself. I have a single x. If I were to graph this, remember your y-intercept, you want to think of that kind of as a starting point. And let me go ahead and put some tick marks. So this is plus 3. So from the origin, I go up 1, 2, 3, and I put a little tick mark. Your slope is the value that is found connected to the x when y is by itself. So in this case, it's negative 1/2. Remember, if you have a negative slope, you go down and to the right. If you have a positive slope, you go up and to the right. This is a negative slope. So I go down 1/2. There's my second point. It only takes 2 points to form a line. And there's an example of a linear function. Now this whole section, 2.1, we really want to focus on second degree polynomial functions. What that means is our equations have to contain an x squared. That's what a second degree term would look like. These are called quadratic functions, okay? And remember, at the beginning, they said one of our goals is to get really, really comfortable with what the graphs look like. So you will notice that a lot of what we're doing today is just really, in a sense, we're dissecting the graph. We want to know every little piece of it, okay? So if I look at this, definition of a quadratic function, you have a, b, and c. Remember, if it's y equals or you set it equal to 0, a is the value in front of your x squared. B is the value in front of your single variable. C is your constant. Remember, a constant is just a number, means it does not contain a variable. Okay, A can never equal a 0. The reason why is because if A is a 0, it'll cancel out your squared term. Then it would no longer be quadratic. Because for a function to be quadratic, it needs to have x squared. If this were to get canceled, you would be back to a linear function. Okay. Often, real-life data can be modeled by quadratic functions. Things like satellite dishes. They are quadratics. That's how you guys have your TV working and your satellite dishes and all that stuff. So quadratics are super important. Okay, so real life, you're going to see a lot of quadratics. Projectiles. When you're playing football and you throw that football up in the air and it comes back down, it forms a quadratic. When you're playing baseball or softball and you hit the ball, the shape that the ball makes in the air is a quadratic. Satellite dishes, I already said that. The flashlight reflectors. So if you have been out hunting and you have your flashlight, you need quadratics. You need that parabola to get that light to reflect. So super important. The graph of a quadratic function, it is in the shape of a U, and that is called a parabola. So anytime you graph a quadratic function, the shape is a parabola. All parabolas are symmetric, meaning that they have a mirror image line. They are symmetric with respect to a line that is called the axis of symmetry. Every parabola has it. Okay, it has a line that goes down the center. Remember, that center point is called the vertex, and we're getting there. But that axis of symmetry, it's like a folding line. If you picture it as a dotted line and you fold in the dotted line, the parabola, the U-shaped graph, would match up perfectly. The point where the axis of symmetry intersects the parabola is called the vertex. Now remember, the vertex is that exact center point. The vertex is, oh, here we go. I'm getting excited. I'm jumping ahead. The vertex is the center point. It will either be a relative minimum, meaning it is at the bottom of the graph, or a relative maximum. And if you picture our parabolas at this level of math, they will only be opening upwards or downwards. When we get to college trig next semester, you will see some that open side to side. It's pretty cool. But for now, ours were open up or down. So if your vertex, the center point, is at the bottom, that is a minimum. If your vertex, your center point, is at the top, that is called a relative maximum point. Let's go ahead and look at the parent function. The simplest type of a quadratic function is a times x squared. Here are some basic characteristics. Now, if a is greater than 0, the value out front, if this is greater than 0, your graph will open upwards. If I look at this graph right here, okay, this is the parent function, it is just x squared. The vertex point here, if it's opening upwards, your vertex is a minimum value because it is at the bottom of the graph. The domain of all quadratics are all real numbers. If you want to do interval notation, remember that means negative infinity to positive infinity. Those two things mean the same thing. So you would not need both. Whatever way you want to show all real numbers for the domain, one of those two options is great. Now your range, if we're looking at our parent function, the lowest y value, okay, remember y, you're going up and down. The lowest y is a 0. So your y values are greater than or equal to 0. Again, if you're somebody who really likes that interval notation, and there's a group of you, I would start at 0, it includes it, and you go up to infinity, because remember, we do not see those solid endpoints here. That means that we are to assume that there are arrows and it continues upwards. This is an even function, okay? It's symmetric to the y-axis. Your axis of symmetry is x equals 0, meaning it's a line that cuts through the x-axis at 0. That is the same as the y-axis here. X equals 0 is the equation for the y-axis. Your vertex is at 0, 0. Decreasing, remember intervals of decreasing and increasing. As you go left to right, your graph is decreasing from negative infinity all the way to this point. At this point, your x value is 0. Then it starts increasing at 0, and it goes up, up, up. That's an arrow, so it goes all the way to infinity. So just some things we've been studying in this class and looking specifically at the parent function for quadratics, which is x squared. Now let's flip this puppy upside down. Okay, what happens if your a value, the value up front, is negative? And in this case, this is negative x squared, okay, just so we have a visual. If you have a negative value in front of your x squared, your parabola opens downwards. If your parabola is opening downwards like this one, there's my vertex. At that point, your vertex is a maximum point because it's at the top of the hill. Your domain, hey, guess what? This is still a quadratic. So your domain is all reals, which means you can have any x values that go negative infinity all the way to positive infinity. Your range, if I'm looking at this graph in particular, negative x squared. Remember, your range is your y value. So the highest y value is 0, and then these are arrows because we do not have a solid point indicating that it ends. So this means it goes forever and ever and ever all the way downwards. So our y value is less than or equal to 0, or that interval notation, This would be negative infinity to 0, and it includes. Remember, the infinities are always rounded. Okay, so I kind of started that backwards. So negative infinity rounded up to 0, the 0 is included. Again, this is an even function. Remember, even functions, you can flip them over the y-axis. Your axis of symmetry, again, is the line y equals 0, which is the same thing as the y-axis. Our vertex is at the origin. Now decreasing, remember you're going left to right. So here this is increasing. Well, I can go ahead increasing negative infinity. It's going up, 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 up till it hits this point. At this point, your x value is 0. Now starting at 0, going down, 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 it's going to decrease all the way forever and ever, amen. Okay, so going ahead and just really looking at all the different pieces of a quadratic and in particular, the graph of the parabola. When you are sketching the graph of the function a times x squared, it is helpful to use the parent function, x squared, as a reference, like we discussed in 1.4. What they're basically saying, guys, is we're going back to transformations. Remember, I promised you in Algebra 2 that these transformations that we studied over and over, they don't go away. And I hope that you're seeing that I was not fibbing at all. Here we are in college algebra, and we have looked at transformations so much, and guess what? Here they are again. If you have an a value that's greater than 1, if you're multiplying it, that means you have a vertical stretch. What that means is you're taking the top and the bottom of your parabola and you're stretching it, so you're making it taller. What happens then is the parabola becomes more narrow. If your a value is less than 1, okay, if it's in between 0 and 1, what you're doing is a vertical shrink. So envision that you are taking the top and bottom of that u and you're putting your hands together, you're shrinking it, trying to make it shorter. Well, what happens when you make a U-shaped graph shorter, it's going to in turn become wider. Okay, so thinking of transformations, what we want to do is describe how the graph of each function is related to the parent function. Okay, so we're basing everything off of x squared. Then we want to graph each function on the same grid. And we can go ahead and use Desmos for that. So the first thing I'm going to do, because I know that this is all based off of x squared, I'm just going to graph the parent function and be like, yo, okay, that's x squared. So I'm going to start off and I'm going to graph that on every single grid because they want us to graph the new one as well as the parent function. So let's just go ahead, grab your notes, sketch with me because this is so much fun. Go ahead and graph the parent function that looks like this. Okay. So here's the parent function. I'm going to graph that in red because that's going to be easier to compare. So everything that we're looking at right now is going to be a transformation of the parent function. Now we need to look at the graph and say, okay, well, what is this? Okay, if I look at A, I am multiplying. It is not in parentheses, so I know it's vertical. So this is vertical. It is multiplying. If you're multiplying, it's always a stretch or a compression. This is 1/3. 1/3 is less than 1, so this is a vertical compression. So what you're doing is you're taking this parabola top and bottom and you're going, get shorter. So what should happen is this should end up wider. So I'm going to go ahead and on the same grid, go 1 divided by 3, so 1/3 over arrow to get out of the fraction. So I have 1/3 x squared, and check this out, it got wider. The reason why it got wider is because what you were trying to do was make it shorter. There you go. Okay, let's look at the next one. So I'm going to go ahead here, get rid of that example. That's why Desmos is so awesome, you guys. Okay, if I look at this again, I am multiplying. I'm multiplying not in parentheses, so it's vertical. The number that I'm multiplying is 2. 2 is bigger than 1, so this is a vertical stretch. So visually, what you're doing is you're taking the top and bottom of this, and you're stretching it to make it taller. Well, when you do that, what's going to happen is you're going to make your graph more narrow. So let's see what that looks like. So if I go 2x squared, that's the green one here, look at that. It was inside of the parent function, because in order to do a vertical stretch to try to make it taller, it makes the graph more narrow. Isn't this cool? I hope you guys are doing this with me, not just watching me, because it's way more fun if you're participating. Okay, now this time I have two different transformations. I have two things that are different than my original, just x and a power of 2. Remember, we did talk about the correct order of transformations. So here I have multiplying and I have adding. Multiplying comes first because your order of transformations follow the order of operations. So I have a negative. Anytime it's a negative, remember that's a reflection. If your negative is out front, it is a reflection over the x. What that means is it's going to flip upside down. Then I have a plus 1. Anytime you're adding or subtracting, it's a slide. This is not in parentheses, so it's vertical. So it's a vertical slide, shift, translation. It's plus 1, so we're going up 1. So this thing should flip upside down and then slide up 1. Let's go ahead and see what that looks like. So I'll get rid of my previous graph. Go ahead and negative x squared plus 1. There's my shift up. Check that out. So it flipped upside down and then it slid up 1. So here is my sketch. So cool. Okay, let's look at the next one. Again, I do have multiple transformations here because the parent was an x squared. So anything other than the x and the power of 2, that is a transformation, okay? In parentheses, if you think of order of operations, you always do what's in parentheses first. Same rule for order of transformations. Originally, the formula, when you're doing a slide, it is x minus h. I'm adding or subtracting in parentheses, so I know that's horizontal. Adding and subtracting is a slide. We have to figure out what direction. Because the normal formula is a minus. In order for this to become a plus, what you had to do is fill a negative value in there. Minus a negative becomes a plus. So we're actually going to the left 2. So this whole graph is going to shift left 2. Now minus 3, adding or subtracting not in parentheses, is a vertical slide. If it's minus 3, that means I'm going down 3. So I'm saying that this should go to the left 2 and down 3. It will still be facing upwards. Oh, there's my dog Peanut Butter. Okay, here we go. Let's get rid of that. And in parentheses, make sure you enter it exactly how it is. So I have x plus 2, close the parentheses, squared, and it's minus 3. So here is my graph. It's shifted to the left and it's shifted down. And there is your sketch of what it looks like. So transformations with quadratics. The last thing that we're going to do today is look at something called standard form. Now the standard form for a quadratic equation, it's also known as vertex form. This is what it looks like. It's a, then in parentheses, x minus h quantity squared plus k. This is super convenient because you can look at this and identify any transformation that occurred from the parent. The value out front, if this is bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. If there's a negative out front, you're flipping it upside down. Adding or subtracting in parentheses, you know if you're going to the left or the right. Adding or subtracting at the end, you know if you're going up or down. So this, they call it the standard form. A lot of it is because of its convenience, being able to identify the transformations. In this form, again, your a value cannot be a 0, okay? Because if that's a 0, it's going to cross off your power of 2, and then it would no longer be quadratic. You have to have an x squared. You have to have a power of 2 for this to be quadratic. The vertical line, x equals h. Whatever h is, that's where your axis of symmetry is. Your vertex is at hk. So whatever you're subtracting from x in parentheses, that's your x value. What you're adding or subtracting at the end, that's your y value. That's the center point. If your value up front, if this is positive, it's opening up. If this is negative, it's opening down. So what we need to do is they are going to give us equations in the form ax squared plus bx plus c. We need to convert it to the standard form by using a skill that we learned in Algebra 2 called completing the square. When you complete the square, we can factor it and get it into that form. So let's go ahead and do this. I have 3 different examples in case you do not remember completing the square. I'm hoping by the 3rd example, you'll be like, oh yeah, I got this. Okay. The first thing that you do when you complete the square is you want to make a separation from your variable terms and your non-variable terms. What that means is I'm going to go ahead and put parentheses around the terms that contain an x, but not the 7 because 7 does not have a variable. Now, before you complete the square, you need to make sure that your leading coefficient, the number in front of x squared, is a 1. This is not a 1. So what I need to do is divide the 2 out. Now, you only divide the 2 from the 2 terms that are in the parentheses. Okay, so I'm just taking out that 2. It does not go to the 7. This becomes x squared plus 4x plus 7. Now that I do not have a number other than 1 in front of x squared, it's time to complete the square. Back in Algebra 2, I said that at this point you need to find the magic number. The formula for that is to take b divided by 2 and you square it. Remember, b is the value that's in front of your single variable. So in this case, it's 4. If I take 4 divided by 2 and I square it, 4 divided by 2 is 2. 2 squared is 4. My magic number is 4. I need to add 4 inside of the parentheses. Okay, but if I'm adding 4 here, I can't just add something in a function. Okay, you have to keep it balanced. So I need the value to remain as 0. So I'm going to add the 4 here, and to keep it balanced, you subtract at the end. Okay, so if I go ahead and I go 2x squared plus 4x, oh, here we go, plus 4 in parentheses plus 7, my bad. So here, this 2 actually goes to all of these terms. So in order to keep it balanced, what I need to realize is here, I actually added an 8, so I need to minus an 8. I just want to make sure that you realize that you're adding it in the parentheses, subtracting it on the outside. If there's a number here, like I have this 2, 2 goes to 4. 2 times 4 is 8. So this actually has a value of 8. So to balance it, I'm minusing 8. Okay. Now what I need to do is factor. You need to find 2 numbers, and they have to be the same number. 2 numbers that are the same number that multiply to 4 and add to 4. Well, that's 2 and 2, because 2 times 2 is 4. 2 plus 2 is 4. So this is x plus 2 squared. Positive 7 minus 8 is negative 1. This is the standard form, okay? It says convert the quadratic equation to standard form by completing the square. That's what we did. Then describe the graph. This graph, when they say describe, what they're saying, you guys, is, hey, what transformations occurred? In parentheses, because that goes first. This is a horizontal slide. Because this is a plus, it means that we must have put a negative in there. So horizontal slide to the left 2. Now I have multiplying and subtracting. You multiply first. So it's vertical. This is a number bigger than 1, so I have a vertical stretch. So the U-shaped graph will become more narrow. Adding or subtracting at the end is vertical slide. Because I'm minusing 1, it's sliding down 1. Okay, your vertex, where's the second, or where's that point going to be? Remember, this is a x minus h squared plus k. Your vertex is at hk. So what are you subtracting from x? Well, we're subtracting a negative 2. K is whatever value is at the end. So the center point is going to be at negative 2, negative 1. This graph is going to open upwards because 2 is positive. So if it opens upwards, this vertex is a minimum. Your axis of symmetry, where are you going to go ahead and fold this graph in half? Remember, it's at x equals h. Well, h is whatever value you're subtracting from x in parentheses. I'm actually subtracting a negative 2. Okay, so we went ahead, we described everything that we could, then identify the zeros and sketch it. So what I recommend, again, I always recommend Desmos. It is absolutely amazing. So if we go ahead and use Desmos, okay, one thing, if you are worried that you did this process incorrectly, we could graph the original and graph this one on the same and make sure that they're equivalent. So what I mean is if I take 2x squared plus 8x plus 7, okay? So that's our parabola. They wanted us to do this in standard form. So I have 2, what we got was 2x plus 2 quantities squared minus 1. If we did that correctly, do you see where it was actually the same graph? So that's just a way to check and make sure that we did this correct. Now the things that we said, okay, it should open up. Yeah, it should open up. This should be a minimum. Yep. Go ahead and tap your vertex. We said it should be -2, -1. Our axis of symmetry, if I go to the left 2, that's where I could go ahead and fold this. Then what you would do is just go ahead and sketch what that graph looks like. All right, let's do a couple more. I know this is a lot, but it's really cool how much you guys can identify already just looking at an equation and being able to do skills that we're doing in class. You can tell so much about a graph. It's so fun. So here we go. Let's look at another one. This is the graph ax squared plus bx plus c. Okay, so they have it in the form where you could go ahead and use the quadratic formula. They want it in standard form so we can really look at our transformations. Step 1, you want to separate your variable terms from your numerical terms. So I put parentheses around the 2 terms that contain x. Step 2, you cannot complete the square if there is a value other than 1 in front of your square term. I have a negative, so I need to divide that negative out. So -1 comes out front. That would make this x squared. Positive divided by a negative is a -6x. I still have the -8 out back, okay? Now, I do not have a number in front of the squared term, so it's ready to find the magic number. Take b, the number in front of x, divide it by 2, and then you square it. -6 divided by 2 is -3. -3 squared is 9. So I need to go ahead and add the magic number as well as its value. I need to add and subtract it, okay, to keep it balanced. So I have -1 out front. X squared minus 6x. You add the magic number in the parentheses. I still have the -8. Now what you need to realize is that this -1 goes into every term in the parentheses, including this +9. So -1 times 9 is -9. I need to keep it balanced, meaning I need to have it have a value of 0. If this is -9, I need to add 9 at the end. Now that's the trickiest part to me, is kind of trying to make sure that you keep it balanced and knowing what this is really worth. This -1 makes this really a -9. So to balance it and make it a 0, you need a +9. Now you factor this. You need to find 2 numbers that are the same that multiply to 9 and add to -6. So that is going to be -3 and -3. -3 times -3 is +9. -3 plus -3 is -6. Now you combine your like terms at the end. This is a +1. So here is the standard form. Now from here, I can identify all of the transformations. Adding and subtracting in parentheses, that's horizontal. So I have a horizontal. Adding and subtracting is a slide. The formula is a minus. This remained a minus. That means I'm going to the right 3. There is a negative out front. So that is a reflection. Remember, if it's a negative, reflection over the x. What that means is that this graph is upside down. Okay? Then I have a +1 at the end, not in parentheses. If you're adding or subtracting not in parentheses, it's a vertical slide. This is +1, so I'm going up 1. Okay, my vertex. What are you subtracting from x? 3. Then I have a 1. Okay, so there's the vertex. If my graph is opening downwards, because this is a negative out front, this vertex is going to be a maximum. Your axis of symmetry, where you can fold this in half, is at x equals h. H is the value that you are subtracting from x, so it's x equals 3. Okay, so I have a lot of information. We want to go into Desmos, and let's go ahead, number 1. Let's make sure that we did this right. So if I graph the original, -x squared plus 6x minus 8. Okay, that's what I started with. Now I can't change the graph. I'm just changing the way that the equation looks. -1, or just a negative. You don't have to have the 1 there. You can have an unwritten one. X minus 3 quantity squared plus what? I did get the same graph. So what happens there is I'm just verifying that, hey, I have the same graph. We said that the vertex should be at 3, 1. Heck yeah, it is. Our axis of symmetry should be at x equals 3. Got that. It should be opening downwards, making this a maximum. So we went ahead and we got that. Okay, let's do this one more time just to make sure. Step 1. You need to separate your x terms from your non-variable terms. Step 2. If there's a number in front of your squared term, you have to divide it out. We don't have that this time, so I can go ahead and complete the square right away. Take the number in front of x, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. So I need to add and subtract whatever the value ends up being in order to change this into standard form. You always add the magic number in parentheses. Now this time, I do have this +1 out here. This time there's not a number here. So when I add 1, it's actually just +1. So to keep it even, I need to -1 on the outside because a +1 and a -1 has a value of 0. So I'm not changing the value of my equation at all. Now you factor. What two numbers are the same number that multiply to 1 and add to 2? Well, that's 1 and 1. So x plus 1 quantity squared, +1 and a -1, when you combine them, you get 0. So here is my standard form. The only transformation I have here, I'm adding or subtracting in parentheses. So that's a horizontal slide. The formula is a minus. This is a plus. That means that I actually put in a negative value. So horizontal slide to the left 1. There's a positive unwritten 1 here, so the graph is going to open upwards. So my vertex is going to be a minimum. The vertex, what are you subtracting from x in parentheses? -1. What are you adding or subtracting at the end? Nothing. Your axis of symmetry. It's x equals h. H is what are you subtracting from x, or subtracting a -1. So we have all of that stuff, okay? Let's go ahead and graph it and see what we get. So let's get rid of the last graph. Again, I think it's a good idea just to make sure that we did this right. X squared plus 2x plus 1. That was the function we're starting with. If we did the math correctly, our new parabola should not change at all. It should be the exact same thing. It's just written in a different form. So I have x plus 1, close it, to the power of 2. Notice it's the same graph. If those two did not line up, you need to go back and check your math. Okay, if it's correct, you should only see one parabola. Now let's go ahead and check. We have a graph opening upwards, yes. So our vertex is a minimum, yes. We said our vertex should be at -1, 0. If I go to the left 1 and I have a line that cuts through the x-axis, that should be my axis of symmetry. That's what we got. Okay, so that is the very first part of 2.1. If you feel like you need extra practice, these are the book questions that I feel like are pretty helpful just to make sure that you really understand what's going on. Notice, like at least this section, when it's odds, you can always check the answers in the back of the book just to make sure that you are on track. I hope you had a great time today studying about quadratics, and I'll see you guys later.